last tutorial of the series. Question: who's gonna be coding live today? You're gonna be coding live? Okay. I mean, of course, like you can follow, like code after. You don't have to do it now, right? But yeah, so the main idea for this tutorial is to learn basically not just how to modify Flexodeal and the main codes that are behind, but also how to do it properly, right? Thinking that more often than not, we will be sharing these codes with other people. Maybe people will continue working on our projects, or you want to code collaboratively, right? So I'm pretty sure you've done this before, right? But what I'm gonna present here is a recommendation. Let's just say a strong suggestion on how things should be done, right? Why? So that we can be sure that, you know, when someone leaves the lab or something like that, you know, someone else can keep on working on the same project, right? All right. So, very briefly, what we've done in the previous two tutorials is basically how to use Flexodeal, right? So in the first one, we started working with Flexodeal Lite, just a block of muscle, simple experiments. Later in tutorial 2, we started using like the full version of Flexodeal with like this more complicated geometry and the use of quadrature points. You know, things become more complicated, of course. But basically, we have been only using Flexodeal as it is, you know, as it comes, right? So now we'll focus on how to modify Flexodeal. And although we're going to focus on how to implement a new feature, everything that I'm going to say in this tutorial, in this presentation, also applies to your personal projects, right? Because you might end up modifying the C++ file or the parameters file. You might end up sharing this with other people, right? So everything applies to that too. And one thing that we've been doing without discussing much is how do we get Flexodeal in the first place, right? So for the first tutorial, we just downloaded a release. It was completely offline. For tutorial 2, we cloned the repository, like just git clone in a terminal. But we never said why we were doing that, right? And here's the thing: when we think about Flexodeal, I always like to think of like in two ways: whether am I testing or I'm just modifying things. If I'm just testing Flexodeal, git clone works. Git clone from the labs repository, right? So from the sfu-nml account, or download a release, right? But if you're going to modify Flexodeal, then what you should be doing instead is forking the repository from GitHub account, right? So when you go to GitHub, maybe let me just quickly open the right, so that's the main website for Flexodeal, right? You have this fork button here, right? That's the one I'm talking about. So if we do git clone, you go here to this button here and then copy the address and download it, right? Or download a release, right? By forking, I mean this button over here. Now, what does that magic button do? Well, if you don't use it, and if you just clone the Flexodeal from the labs account, first of all, you can only perform local changes. You can't create any remote branches, right? Branches are where we're going to store our sort of like temporary work, so to speak, right? And you cannot track any of your changes, and we'll go into details to what track your changes mean, right? However, if you fork Flexodeal and then clone this repository from your account, because when you fork a repository, basically you're sending a copy of this repository to your own GitHub account, right? So in a sense, it's separate, right? You can edit things in your account, you know, create new branches, modify things as you like. You're not going to be modifying the main repository, right? So there, if you fork Flexodeal, you can create multiple branches. Say you're working on different projects, they all require different modifications of Flexodeal. You can have separate branches for that. You can also fix the version of Flexion that you're using too, in case there's any particular feature that, I don't know, it was present in version 1.2, but for some reason it got removed in version 1.3 and you want that old version. You're free to do so too, right? It's possible. But of course you need to fork that repository first. Now, I'm gonna talk a lot about tracking your changes, and I think this is one of the things that it really makes a difference when you start using it. And why should you do so? Well, there's plenty of reasons. First of all, reproducibility, right? You can recover the exact code that you use for your results, you know. There's consistency, especially if you're working with collaborators. Tracking your changes also helps you in debugging and validation, right? Because you can see where you modify each line, or even like say you go to a particular line in the code and see who did that, when was that done? Is that part of the original upload? Is that part of a later modification, right? So if you're trying to figure out why things went wrong, right? Well, tracking your changes help you. Collaboration too. It's a safe way for multiple people to work on the same piece of code. Project management in the sense that you can work on different projects, keep them separate with different branches, you know, and you're always gonna have that sort of like reference version of Flexodeal, right? And then all your branches for your separate projects. And finally, long-term research value. Again, if in 5 years down the road, someone else wants to look at the code or wants to look at the results from your paper, they can take that code, and assuming that you upload a code that works and it's reproducible, then later that person can also reproduce those results, right? So as I said, the main goal for today is to include a new feature. In particular, we're including intramuscular fat in Flexodeal Lite because that's something that is not present. We have it in Flexodeal, but we don't have it in Flexodeal Lite. So the choices that we're gonna make here are based on what was done in Flexodeal, right? Of course, in Flexodeal, because it's a more complicated code, there's more things to do, so this is like a watered down version of what's there, right? But in terms of the models, right, just like the mathematical models, so to speak, they're the same. And of course, we're gonna do this in a track setting. And if you have any questions, feel free to interrupt as I speak, because maybe there's, for some of you, this whole Git thing, you might know it, but if you don't know about it, like, feel free to ask, right? Because there's a lot of new terms that we haven't discussed much in previous tutorials. So, like I said, what we're gonna see today also applies to your personal projects. And one way to do things in a structured way is to think about this new feature as part of a larger software, and like a mini piece of software that you're developing. Well, when you develop a new piece of software, most of people follow what's called the software development lifecycle, right? And it begins here with a requirements gathering and analysis, right? So first you have to figure out what you want to do, whether is that feasible or not, you know, discuss about that. Well, then you think about, well, I mean, I want X thing, how am I gonna implement that, right? Once you have an idea on how to implement that, well, you start coding and you start testing, and you might end up in a loop here of coding and testing, especially if something doesn't work the first time, which is probably most of the times it won't work the first time. So you have to go back to code and test and code until you get a result that you like, right? And then deployment, so once you've already coded everything and tested and you're happy with the results, how do you include that in Flexodeal, especially if, and this applies especially if you're developing a new feature like what we're gonna be doing today. And afterwards, right, maintenance and support, right? So your feature is already there, it's working, but one morning someone comes like, hey, I tried X experiment and it didn't work. Turns out they had a bug in the code, right? So how do you fix that bug? Well, that's part of maintenance. And sometimes maybe the bug is just really big and you have to just rethink about things, how you're doing things, right? So that's why it's a cycle, right? Because then eventually you go back to the first step. You go back to the drawing board and continue iterating. So in the context of implementing or introducing FAT into the model for Flexodeal Lite, we're going to follow each one of these steps. So that's pretty much what comes next. So the first part about requirement gathering and analysis. So a couple of things that we have to discuss, right? So first, what is the objective? First of all, what do we want to do? Well, we want to capture the effect of intramuscular fat on active muscle dynamics, right? We have the active muscle dynamics part. We don't have the intramuscular fat part yet. What's the modeling approach? Again, we did this in Flexodeal and it has been done in the lab in the past. So we continue with that idea of, just using a homogenized strain energy function. And of course, there will be details about that. We assume fat to be isotropic, quasi-incompressible, and uniformly distributed. What inputs are we going to need? Well, they're also given by the modeling approach you pick, right? So in this case, at least we're going to have a fat fraction. That's at least one parameter has to go there. And then any parameters that define the model for fat, right? There's different types of strain energy functions that you can pick. For some of them, you require one parameter. For some others, you require three parameters. It's a choice, right? But also, when you think about like a new feature, you should also be thinking about how are you going to validate that? How are you going to test that, right? So that's how you sort of like narrow down the scope of the things that you want to do, right? So for this particular case, well, we don't have exactly experimental results done in a block of muscle exactly like the one we have here. But we know that with increasing fat fraction, you're going to have decreasing force generation. And this decrease has to be somewhat proportional. It has to make sense somehow, right? And we'll see why. But those are like the kind of tests that you should keep in mind first. Okay, I'm thinking about this new feature. How am I going to test it? How are you going to implement it? That's the next step, right? Some constraints that we want to keep here, well, it has to be backwards compatible, meaning if you put zero fat fraction, you recover the original results, right? We shouldn't modify too much of the code. It shouldn't be necessary. And it's always, I think, also useful to consider things that are out of scope here. What do I not want to do? Say, for now. For instance, we would say clamps, spatial heterogeneity. Everything will be uniformly distributed. If you want to do clumps of fat, well, that's Flexodeal, right? Say things like a viscoelastic model, like a more complicated morpho fat. We're not interested in that yet, right? So start with a simple thing first, and then you can move on to other things. Any questions? So the next step in the software development lifecycle will be system design. And when we're talking about scientific software like the one we're working with, there's not only the computational details to think about, so sort of how you link your classes and whatnot, but also the mathematical details, right? Part of like knowing how are we going to implement this is being clear about what are the equations that we need to modify. And there's just a bunch of equations here. Let's see. So I've included the ones that we're going to be adding to the code. The first one that we knew pretty much from the first tutorial. It's always based on strain energy functions and hyperelastic materials. The volumetric strain energy, well, now takes this form. Originally, it only had a couple, like one bulk modulus, but now this bulk modules, it's divided into two parts, weighted by this fat fraction here, this kind of fats. Then the isochoric part of the strain energy, well, it also gets sort of like average in this sense. The two terms here, the strain energy for muscle and base material, that's already in the code, right? So that we don't touch. But more importantly, the stresses are the things that we need to include. Where's my courses here? So the stresses, right, for fiber and for base material, that's already in the code. But we need to add these terms, right? And of course, we need to define the stress for the Kirchhoff stress for fat, and the expression is given over here, right? And you'll see how to implement these terms here because this invariance I1 and also this tensor B is also part of the base material implementation. So they will be right beside each other, right? And same way the elasticity tensor, so the fourth order elasticity tensor that you use to solve your linear systems, well, it takes that form, right? Again, this is a choice. There are other choices for materials, right? This is a choice that was used in this paper here. So we need to add 6 new parameters, and we decided to take the following default values. So maybe just leave 2% fat, things like that. Then some constant that defines the material, and a fudge factor that should be taken as 1, but it gives you leeway to take it higher if you need it. So once we've figured out what we want, how am I going to do it, and also to a degree how am I going to test it, well, now we can start coding, right? So let's see. I'm going to just open VS Code here and start getting things as here. So maybe I'll go through these steps first, and then I'll do them. So first is forking the repository, and I'll show you how to do that. Then we clone this repository from your account. So then we go to the folder, and before starting doing all the CMake stuff that we used to do to compile the software, well, we take a step back and create a new branch. So like we start from the main project and then just take a detour, right? Because we're gonna start doing something new. And then we have to basically tell our account, because when we do this git checkout step, right, I'm only creating a branch locally. I need to upload that to my GitHub account somehow. That's when git push the last line comes into play. Now, when you do git clone, right, and you use the HTTPS address, right, it works, but that is not the ideal way of doing things, because when you do that, when you do this, you're gonna get asked every time you do like push this kind of step, you're gonna be asked about a username and password, but your password is not actually your password. It's actually something called a personal access token, right? And this is GitHub because of security reasons, right? So my advice is that you clone this using the SSH address, and we'll go over that. But that requires you to sync your machine's SSH key with your GitHub account. So that takes a couple more steps. You know, you have to generate and link it with your account and everything. So we're not gonna do that here. So feel free to go back to this slide, click on this link, and how to do this. Like really, it will make your life easier, a whole lot easier. So let's go back to browser here. So assuming you're starting here, right? Back to the Flexodeal line, and we are in the lab's GitHub account. So again, so you should have this button here. It says create a new fork, right? Now, of course, if you don't have any other accounts linked or organizations, you're only going to have yours, right? Now, I can't select mine because I already forked this repository, but if you haven't done this, then you should be able to do so. You can change the name if you like, and then you create a fork. So when you do that, then you should have pretty much a copy of Flexodeal Lite in your account. So I'm going to go to my repositories here. And you see that the first one here says Flexodeal Lite forked from the labs account. So I go there and just look at the username here just to figure out where you are in terms of like in what account you are working with, right? Because of course the repositories look the same, right? So this bit looks the same, but of course this line here tells you that it's a fork of something else, right? So from here you can clone the repository. Notice the address, right? So it says github.com/myname and then Flexodeal Lite, not SFU NML, right? So I could do git clone using this address, but again, I will need the personal access token. You can do that. But just to keep things simple, I'm going to use the SSH address, but that is because I have my SSH keys here, right? So I've linked them already. So let's go. I'm going to go to my sandbox folder here. And again, I'm cloning Flexodeal Lite from my account. So you're just doing from your account, right? And then we navigate to the folder. So then we have the contents of the repository. If I want to check on which brand I'm working, well, I can do this command, so git status. And it says on branch main. So I'm on the main branch of Flexodeal Lite, forked from your repository, not from the labs account, right? So then I create a branch here. Let's call it fat implementation. So it immediately switched to this new branch. You can do git status again. So it now says on branch fat implementation. So now I'm going to tell my account that I have this new branch locally and I want to link things. So I'm going to do the last line here, git push -u origin and then the name of the new branch, fat. So now this branch here, which was local, is set up to track a remote branch. This is what we want, so that way we can start like adding our changes, right? And again, this worked for me right away because I linked my SSH keys, right? If you're cloning with the HTTPS address, then there would be like username and password and personal access token and all of that. Any questions up to this point? So, okay, I downloaded this repository, I created a new branch. So now it's safe to start working on this one, right? Let me put this to the side. So what's the idea here? There's a lot of things to do here, but the first thing that I always suggest to do is to get a copy of like your original results basically. So run an experiment, the one that you're interested in, with the code you just downloaded, and keep those results separate, because then you're gonna need them to compare, right? So any modifications that you're gonna do, you want to, they have to be backwards compatible, right? So at some point, if you take no fat, right, you have to go back to the original results, right? So that's the first thing I'm gonna do. I'm going to, of course, compile this. We've done this before. And because I want to test things using an isometric contraction, that's the example I'm going to be focusing on. So we have in this repository an isometric contraction of just a parallel fiber muscle, so just muscle tissue, nothing else, and just parallel fibers, right? Why? Because that we know in that example that when there's no fat, the force at the end is about 20 newtons, right? So that's sort of my benchmark experiment. That's the one I'm going to use to implement this and to test it eventually, right? So that's the example I want to run. I have my executable right here. So I can call this. Samples, PRM, boundary strain. And examples. We already went through this example in the first tutorial, by the way. So it's the same thing. Let's call this results original. I think everything's all right. And it will run something. Shouldn't take too long. So while this is running, and this shouldn't take more than 30 seconds, but while this is running, I'm just gonna go to Visual Studio and open the folder that we're working in. So I was working in my sandbox folder here. There we go. All right, so results are done. Again, the force at the fixed ends, well, that's about 20 newtons. Those are the results we had from before. In this case, took like 51 seconds. So you can see the new folder here, and to me, when you're tracking your changes, when you're linking everything with GitHub, you can take advantage of all the features that VS Code have, right? For instance, you see the results original folder with the one that we just created with this green dot here. They mean that these results are, this is a new file that is not tracked by GitHub yet. You can add if you want, but of course you're not going to add the whole folder with the results, right? So now, there's a few things that we need to modify, and there's this file that I wrote here, this markdown file. So I'm going to go to the tutorials repository. Because we had mathematical details for the system design step, so now we can discuss the implementation details, right? We said that we needed 6 new parameters, and they're here, 3, 4, 5, and 6. 6 new parameters. We need to add this to the parameters section, of course. And because we're going to be working with this isometric contraction, we're just going to add it here for now to that parameters file. And of course, once you do that, afterwards, right, after you've tested everything, you're gonna have to modify all the other parameter files that are in the repository, right? Because there are gonna be new parameters, right? The code will be expecting new parameters, so the other examples better have them. Let's see if I can put this side by side here. I want to get rid of this. Does anyone know how to get rid of this side? I'm pretty sure yesterday it had an X button there.
No, like top right, you have like your panels. You can just untoggle top right.
Ah, there we go. So let's modify first the parameters file, right? So I have it right here. And I need to add this section. So we have the materials section with all the fiber and base material properties. I'm just gonna copy this and paste it over here. So now, this file, IC_parameters.prm, it has an M next to it. That means we've modified it, right? And you can see exactly where we've modified it because of this, this green line here. Right? And every time you modify, say, for whatever reason, I modify that line, you get a blue line there, right? So blue line means modified line. Green line means new line. So now we've added new parameters. We need to tell Flexodeal about these new parameters, right? Somehow. So that's when we jump to the next bit here. And now we're gonna go to the C++ file. So of course there's a lot of things in this C++ file. One can do like a whole code review about that. Yes?
I have a question. Is there, how we can find the limitation, if there is any kinds of limitation for changing the each code according to the code you have applied?
What kind of limitations?
For the numbers, for example, for the time, for a string, for whatever we want to modify, is there any kinds of limitation? We should notice them?
I mean, in terms of like what you can code, well, anything. Whether it will work or not, that's different, right? And of course, it depends. That depends on the particular example you're working with, right? So there aren't like set thresholds, basically. Yeah. Of course, if you put like I don't know, like a fat fraction of like 1,000, chances are your code won't run or something else, or it may run, but of course it will give you garbage, right? Yeah. But we don't have any like set thresholds.
If you want to find, you can check the papers that you...
Yeah, of course, or you can just try it.
Yeah.
Yeah. Yeah, we didn't add any like thresholds because we want people to push this code, right? And then when it breaks down, then I want to know about that, right? Any other questions? So we're adding intramuscular fat to the model, meaning that we're going to have to modify classes and parts of the code that are related to the properties of muscle. The first one is this chart over here, so I'm just going to search it up. Properties. Because the also has a particular way of dealing with parameters, right? And that's with the first this first part in the code is all about, right? And all parameters are parsed in the same way and defined in the same way. Basically, you declare them, or say you define them first, then you declare them, and then you parse them, right? So 3 steps. So that's what we need to modify here. Now, I just remember, I already did this just to make things faster. It's like, like the cooking shows, when they tell you a recipe and then the food is already cooked separately, right? So I'm gonna do that. I think this is already in, this is also here, right? So you may replace the contents of this file, so the one we're editing, with this one. And this is also in the tutorials file. So I'm going to do that. I'm going to download this file. I'm going to briefly go back here. And I'm going to download this file. I'm going to open this folder here. And also open my downloads folder. So I'm just going to move this file over here. So I can close that. I'm going to do a little bit of cheating here. So you notice that we have our original Flexodeal Lite file and then the one with fat. So I'm going to rename. Actually, I can do it here. I don't need the terminal for this. Let's call this the backup. I don't want to lose it for now. And then I'm going to rename this as the original one. And with this, VS Code will think that, oh, I've modified the file, right? Has an M here. So now I'm just going to close the terminal here. And you can see the new lines here that I'm adding. So again, I needed to add 6 new parameters. I have them here. They're all doubles. Then you declare them with this structure. Basically, using this function, you have the name, a default value, what are the parameters like string or double or integer, and then more documentation about it, right? Typically, we just if the names of the parameters are descriptive enough, you can just repeat the description of those parameters, right? So there's 6 new declare entry lines. And 6 new for this parse parameters section, right? So here is where here's where the code actually goes to the parameter file, looks for this line, and then stores the results in these variables here. So it's the same structure over and over again. And this is a very particular way that DL2 has to deal with parameters. Other programming languages are simpler in some sense too. I think one of the main limitations of parameters files is that, in this case, is that they only accept like single numbers. But say there are other files, like other parameters files, like TOML files, like TOML files that are typically used in Python. And there you can use vectors too, right? But they are not supported yet in DL2, right? So unless you develop like a separate library to parse these parameters, it looks clunky, but this is what we have for now, right? It works. So that's with respect to the parameters. I'm gonna go to the details here. So modify the parser, the muscle property is tracked. At this point, all I've done is read the parameters, nothing else. I haven't used them. So now I have all these 6 variables to use throughout the code. And that's what we're gonna do. We're gonna go to the next modification. Down here. So again, green lines means new line, blue lines means modified line, and if you want to figure out what was modified that from, well, you click on the line and then you can see the green bits are the new ones, and then the red bits are the deleted ones. Again, this is all possible because you're tracking your changes, right? Now, what is this, briefly, what is this class? At each quadrature point, there's a pointer to a member of this class, because this is where all the properties are stored. So basically, any property that is assigned to a quadrature point is here in this class, right? So you can store all this information in that single quadrature point, right? Including, of course, fat information, right? That's why you have these extra lines here. And this is just the constructor of the class, right? That's what we're modifying here. So of course you're going to have these new parameters, and this modification it's worth visualizing. So I'm just going to put this on the side for a little bit. So in here, for the volumetric strain energy, the original one only had a kappa, just one value, kappa muscle, right? But now it has like this sort of average, right? That is exactly what we have implemented in this line over here. Sorry. So in this line over here, that was the original line, just one value of kappa. That's the modified line. So 1 minus fat fraction times bulk modulus of muscle plus fat fraction times bulk modulus of fat. So that's how these changes are reflected throughout the code, right? So that takes care of the bulk modulus. Then we need to take care of these stresses, right? So I now have in the class all these new members. Of course, I need to define them at some point, right? Right, so they're projected members. And up here, I modified the stresses here. So, right, where was this? Okay. Well, the fictitious Kirchhoff stress, what was that before? Well, in the red line here, right? So active stress plus passive stress plus base material, nothing else. But now that we have fat, well, we have to, we have this weight here, 1 minus fat fraction. And we have a new one for fat, so the Kirchhoff stress for fat. Right, so we have it right there. And that is defined down here, so you can compare this expression to what we had in here, right? So tau bar fat here is precisely what we have in these two lines here. And this is what I meant when as for like the definition of this invariant, so I1 and then the tensor B here, they are the same ones used in the base material part because the models are the same, but the constants are not. By the models are the same, I mean the equations or like the root model, so to speak. These are all Yao strain energies, right? But of course, you can fit them to different materials, right? So for base material, they're fitted one way. For fat, they're different. They're fitted in a different way. That's why even though the expressions look somewhat the same, the constants are different, right? So it's not exactly the same model. I hope that's clear, right? The structure is the same, but the model is actually not the same. Just the structure. So, and in the same way, any questions so far, by the way? I mean, I'm just making parallels here. Feel free to, after the tutorial, like dive deeper into the code, because of course there's a lot of things, right? The elasticity tensor, well, same thing. It was just active elasticity plus passive elasticity plus base material. Well, now you have the same expression here. Now, because we have modified the constructor of this class, right? At some point we're calling it, and we have to modify that as well, and that's the last modification. So when I'm setting up all the list of quadrature points, right? At each quadrature point there will be a pointer to this class, right? Which is defined here. Of course, I modify the constructor, meaning that I have to modify the way I'm calling this, right? And this is consistent with the definition of the constructor that we did, right? So that's why we are adding these new parameters. And those are all the modifications we need. If you need to see these modifications side by side, I really like this button here, says source control, because then, and I'm just gonna maximize this. So you can click here in your modify file, and then you can see the differences side by side, right? So new content there. Say down here, I did not raise my hand. Where's this? Things here, like the little lines here, they were replaced by this. This line here was replaced by this, and so on and so forth, right? Now, I'm seeing that it's already 11:22, so I wanted to like run the tests here, like live, but we're not gonna have enough time, so just gonna go back to the slides. Because the idea is now to run 4 simulations. I mean, you can do it afterwards, we're not gonna do it here. But one of the many tests that you can do is to compare forces, right? And we can use this output to verify that first the output for fat fraction equals 0 matches the output of the unmodified code, so the one that you got previously. And then verify that as the fat fraction increases, the total force at either end decreases, right? And I already did this here. These are the results I got here, so let me just maximize this for a little bit. Let's see. There we go. All right, what do we have here? So this is something that I just did with the CSV files. I just copied them into Excel, like a new sheet, and started working on this. Nothing more, nothing too fancy, right? So this is from that file that was in the previous slide, so the force data, right? So in the first column, I have the original results. So at the end, the force again was kind of close to 20 newtons. For fat fraction equals 0, I get the exact same results, which is what I want. And then for 0.02, 0.10, and 0.20, or 2, 10, and 20%, I get these results that are plotted here. So we see that it changes. Well, for 2% fat, the force decreased 2% approximately. For 10% fat, it decreased 10%, and then for 20%, it decreased around 20%. Does this make sense? Does it make sense to you, James?
It does.
Why?
Well, you're increasing the stiffness of the base material. One thing which is not in here is changing the fiber force component. But this is just the base material. Because I would expect force to go down more than 20%.
So in this particular example, right? Because the primary component, not the only one, but the primary component of force is done by fiber force, right? And the fiber force is weighted by this 1 minus fat fraction coefficient, right? That's why we're seeing this kind of like much closer to the 2, 10, and 20% mark, right? There are other forces, of course. When we put the whole picture together and look at other forces, you will see probably further decreases, right? But this is only, and we're only looking at the force at one phase, right? And this is a very simple experiment too. So one could even like run this with like more time steps, a finer mesh, and then see the results, right? But yeah, it's the fiber and the base material components are weighted by the same factor. Yeah, not just the base material. Yeah. And again, this is just one test out of the many tests that we could do, right? So, okay, you've wrote code, you've tested it, maybe you did a bit more loops just to fix some bugs and whatnot. So now there comes this classic cycle or workflow, you know, of adding your changes, committing them, and then pushing them. So I'm just gonna do that briefly here. So if I do git status, it tells me that, well, I have 2 modified files and then some new files here, right? I want to only add these 2, right? I don't want to add these other 2 files. So I want to do git add. And the files that I've modified. If I do git status again, well, now these files are state because I just did git add. That's what the name of step is. Then I commit my results, meaning I'm going to describe them. What did I do here? So let's say added intramuscular fat. And of course, your messages should be descriptive, right? Not like fixed bug or added new lines. No, like they should be descriptive of what you're doing, right? And then we're gonna push my changes. So if I go back to the main repository here, so my version of Flexodeal Lite, not the labs version, right? I can see that there's a new branch. There have been recent pushes. And let's look at this file, right? So you have now the file with the new section here. Where is it? You have the fat properties here, right? Because you've added already your changes. And then, very briefly, there are some good practices. Like I said, use meaningful commit messages, push regularly so don't accumulate big changes, right? And then there are other phases in this life cycle that, again, if this is particularly important if you're adding new features, not so much if you're working on your own personal projects, because you could just work on your personal branch, add changes there, and just keep it there. This is more like if you're either adding new features or planning on releasing this to the public, right? And well, it goes beyond coding. We modify one parameter file. That means that you have to modify all of them, right? Of course, I'm not part of this particular project, but if someone else downloads Flexodeal and wants to run another example, they're not going to be able to do it, right? Updating any README files, maybe release a new version depending on where you're working. Now, the main message here is that we can think about many new features for the code, right? But before doing so, we should be asking a couple of questions. So first of all, is the feature broadly useful, right? Say I want something new in Flexodeal. Well, is it something that works only for my project, only for this particular project, or is it something that can be generalized, right? Is it testable, right? Can you do like a couple of tests to verify the correctness of it? Is it reproducible? So can others download your code, run it, and get the exact same results? And more importantly, is it documented, right? Is it documented, like the models, the tests, everything, right? So those are important questions to ask before thinking about a new feature. Once you've thought about a new feature, how to do it, how to test it, then it's much better to implement it because your goals are clearer in that sense. And finally, when it comes to maintenance, again, especially important if you're at a new feature that's going to be used by everyone, right? Well, your typical bug fix or developing use cases, they're all part of this section. But like the main thing here is always prevent regressions, right? You don't want to break the code. Never break the code, please, right? So yeah, I've said this many times in this presentation/tutorial. But yeah, I think I've mentioned all of them. Perhaps the last one is the one that I haven't said explicitly. Like reuse the code, don't duplicate it unless you, don't duplicate it and don't rewrite it unless you have a very good reason to do it, right? So yeah, we already had that slide from before. So yeah, any questions? Any questions, general concerns, or ideas?
So,
Yes.